I'm going to do chapter 9.4, which is a hypothesis test for a proportion. I'm going to go through the example, which is 9.6, page 310. It says, McDonald's currently fills 90.9% of its orders correctly. It has designed a new process that they hope will increase the proportion of orders filled correctly. Increase being the important word there. That tells me it's a one-tail upper test. A sample of 400 orders found that 378 were filled correctly. The 0.01 level of significance, so alpha is 0.01, can you conclude the new process has increased the proportion of orders filled correctly? So here's our null and alternative. Pi is less than or equal to 0.909. That's population proportion of orders filled correctly is less than or equal to that. The alternative is the proportion is greater than that amount. 0.05 is alpha. Sample size is n equals 400. The z-test of proportion is what I want to use because there are no means or no standard deviations talked about. The only information we have in the problem is x over n. So P, which is x over n, is 378 over 400, or 0.945. The test for normality says we want to make sure we have a normal distribution for this test. N times pi and n times 1 minus pi have to be at least 5. So if we use the value for pi, 0.091 times 400, that's 36.4. 0.909 times 400 is 363.6. Therefore, we can assume a normal distribution. They're both a lot greater than 5. Step 4, here's my critical value from the z table, 2.33 positive. Calculated value is 2.5034 based on what it says in the book. And therefore, I'm going to reject the null with 99% confidence. I believe that the new process has increased the proportion of orders being placed correctly to more than 90.9%. So therefore, I'm willing to change policy. The p-value for this problem is 0.0062. That's less than 0.01, so the answer is not sensitive to alpha, and it tells us we can have 99.38% confidence in our decision to reject the null.